start recording again. Okay, so inspiration for quadratics. What is so great about these things? So where did I move? That is a very good question. I'm going to turn on my video so you can see where I am. So there are several of us who are sort of living together, like as a family unit almost, and so we're not, we're distancing with our own like actual families. So I went to a friend's place, so we've been distancing pretty aggressively with the outside world. We're not with each other. So. Yes, so that's where I am, and you can see these lovely pens behind me we made for Thanksgiving. So anyway, so I'm with friends, and none of them have the virus. So you can be sure. Okay, great. So I guess let's resume. Yes, thank you. Yes, very beautiful. Okay, there are 22 people here. I'm just going to kind of continue. So this is really out of anyone's control. So I wish things could go differently. Anyway, what makes this so important? Well, in a world where we have this thing called uniform gravity, Newton showed that if you wanted to get from gravity, so this notion of acceleration, to this notion of position, or like how high you are or how far you are, here you are on this plane, or in this 3D space actually. So if you want to get from here to position, Newton showed that you need to go through this world of quadratics. And for the seniors, you'll learn in calculus that this pathway is actually very straightforward. And position and velocity and acceleration are all related through this notion of the derivative. So this is sort of inspiration, but quadratics show up in more than just a physical problem. They show up in the theory of differential equations. They show up in linear algebra. They show up, like Adi mentioned, in economics. It's truly like a vast subject. So being able to find the solutions of a quadratic equation is a life skill. For example, like in the case of gravity, if you threw a ball, right, and you wanted to find where it landed, this thing, what's the name of the shape, given that you know what? Just anyone.
I didn't hear the question.
What is the name of the shape?
Oh,
if you throw a ball,
parabola.
Yeah, it's a parabola, and so it actually turns out that it's not exactly a parabola, but it could, trajectories on for small masses on the Earth can be approximated by parabolas. And so, say you threw it at time as 0, and you wanted to find where it lands. Well, you'd have to solve a quadratic, some quadratic equation of this form ax squared plus bx plus c. And so, just to solve, this. And so I don't know how many of you saw the SpaceX launch a few weeks ago, but they do this really cool thing where they recover their parts. They recover their engines, and they recover their rocket boosters. And so this is basically what they're doing, because they launch the rocket, and it's not traveling in a parabola because it has boosters and stuff, and it's not just subject to gravity. But at some point they let go of their used fuel, and they recover that. And so from here on out, you get a parabolic trajectory, and they're basically solving the quadratic. It's this basic quadratic equation. And often they use the quadratic formula because that is the general solution to the quadratic. So anyway, let's pause on the assignment, okay? And I'll give you at 10:45, so just in 25 minutes or so, I'll stop the lecture, and then you can finish that up. It's really a completion sort of thing, and I really just want you all to get some practice. But let's just sort of review what we've learned, and let's do a few examples before this assignment. So we have 3 big ways to think about quadratics. Can anyone name these 3, or at least name one? What was the first way that we talked about?
The quadratic formula.
Very good. Yeah, the quadratic formula. So don't worry about the assignment right now. People are starting to ask questions about the assignment. don't worry about the assignment. We'll just kind of put that off to the side and let's focus on this. And this will actually make it a lot easier. So yeah, so we talked about the quadratic formula. And can anyone remind me what that is? Like, just tell me what the quadratic formula is.
X equals negative b plus or minus the square root of 2a minus 4ac over 2a.
Very good. Yeah, and so this is the general solution to the quadratic equation where you have, a, b, and c defining the coefficients of each term. Then we talked about 3 special cases, and I had written those in green, and that's why I've used green here. Can anyone remind me what those 3 special cases are of quadratics? They weren't so long asked in the chat. Solutions ? So first of all, this is all you technically need. Is the quadratic formula, because that gives you a solution to any quadratic. But we talked about some easy ways to identify patterns in quadratics, and one of those patterns was the sum of 2 things squared. So I think I used b, so I'll be consistent and stick with b. So we talked about this, and what does this equal? I'm not sure people are really with me here because the assignment is out.
No, I get it.
Okay, you do get it. You can use the sum of one number and the factors of the other is what Selena said. I'm not sure exactly what you mean, but if you wanted to, you could FOIL this out. People who are experienced and people who took my encouragement yesterday to memorize this sort of fact. So Selena, you're talking about you're talking about what we talked about most recently, which was sort of end of yesterday. But what does this mean? This is just x squared plus 2xb plus b squared. And then there's also this thing where the same thing with just a minus sign. And what's different about this? How does this look different from that?
It's negative 2xb.
Yes, exactly. So the only thing that changes is the sign. And how about the third case? There was a third sort of special case. It's okay if you don't remember. It was, I'll use b again. It's the difference of squares. And so these are 3 cases that come up everywhere on the SAT. And if you see them, if you see something of this form or of this form, you should immediately know sort of how to go back and forth. So these are worth memorizing. And then yesterday we talked about sort of what Selena said. I think you summarized it very well. So let's just do a few examples and then you guys can get on with the assignment. So this will just take 10 minutes or so. So can someone walk me through this one? Y equals x squared minus 7x minus 30.
We can do that thing that you showed us like yesterday, that like x times x, right? And then like on the other side.
So you can list the factors. So sort of big picture would be, first of all, does this fall under one of those special cases, 1, 2, or 3?
No.
No, that's very good, because just by inspection, you can kind of tell that this is not the sum of 2 things squared. It's not the difference of 2 things squared, and it's not the difference of squares. So we can't use.
I mean, it's 3 and negative 7 by inspection.
It's 3 and negative 7. I don't think it is. So we could play this game.
Oh, my bad. That's not what I said. 10 and negative 7.
Very good. Yes.
And 10 negative 3. I can't.
Negative 3. It's actually negative 10 and 3. Okay.
Yeah.
So I don't want to feed the answers to you all. But for the sake of kind of getting through these things, I'll just sort of do them and try to walk you through them. But I want you all to be at the point where you can do them on your own. So sort of the method is to multiply, to find 2 factors of this number and to find 2 factors of this number. And then notice that, this number, the top number times the bottom number, added to the bottom number times the top number should be equal to the middle term. And indeed, 3x minus 10x is minus 7x. So this is the correct sort of factorization. And then your solution, or at least the factorization, should be written as you go across. X minus 10. See, I'm literally just reading across. X minus 10 times x plus 3. And if you wanted to verify, you can multiply, you can FOIL this out, and we talked about foiling. So this should be the correct form. And if I wanted to verify, I would do this first outer inner last business, and I would get x squared minus 7x minus 30. So indeed, so this is correct. And what if I were to find the solutions of this equation? First of all, what does solution mean?
It's the x-intercepts of
The x-intercept, and that means that y is 0. So you set this thing equal to 0, and then you apply which property?
zero product property.
Very good, nice. And so that tells you that the zero product property is, if a times b generally is 0, then either a is 0 or b is 0. So that's exactly what I'm saying here. Either this is 0 or this is 0. And these are linear equations that are very ridiculously easy to solve. And these are your zeros. So everyone happy with this? I assume so. Okay, let's just do another. So can someone besides Audie, so Audie has been participating a lot, which I really appreciate, but can someone else tell me what some possible, sort of which approach should we use for this? Is this a special case?
No.
No. And so we're sort of either left with the quadratic formula, which is a bit less intuitive, but it always works, or we can do this method of sort of guessing solutions. And so can anyone give me some guesses?
7 and negative 5.
Positive 5.
Good, yeah, great. I think you all are catching on very well. So 7 and negative 5, and we know this works because x times negative 5 is negative 5x, and when I add that to x times 7, which is 7x, I got the middle term, which is 2x. So that works. And then what are the factors going to be? Can someone tell me?
X plus 7 and x minus 5.
Great, very good. And so what would the solutions be? So this is y. So how would I find the solutions to this quadratic equation?
You said equal 0.
Right? And then I'd get these as the solutions. Okay, great. So I think we can skip a few of these examples. Let's try this one. Is this a special case?
No.
No. And can anyone guess the solutions then? Or guess the factorization?
Negative 2 and 1.
Negative 2. Okay, so you just told, that's awesome that you just told me the solutions. I don't know if these are the solutions, but you made a bold move, a bold guess.
Negative 1/2 and 1.
You think it's, okay, so here are some tests. So this is always a cool kind of way, a sort of game to play. And so if you want to check if these are solutions, you can just put them in, right? And if we were to put in negative 2, we'd have 2 times 4 minus, so it would be plus 2 minus 1. So this unfortunately does not equal 0. Right? You would want the left-hand side to be 0. So 2, so this is not a solution. 1, yeah, 1 is. So you all can sort of play around and guess solutions, but if I were to do this sort of using method 3, I would write the factors 2 and 1, and then 1, negative 1. And I chose that because 2x times negative 1 is negative 2x, plus x is negative x, so that gives me the middle term. And so my factorization is this, right? Reading across. And using the zero product property, I would say that 2x plus 1 is 0, and x minus 1 is 0. And indeed, this gives you x is 1, and x is negative 1/2. So Audie's solution was correct. So Audie, did you just guess, or did you do this really quickly?
Basically, if it's, I was like a really quick way is like if the top, so if the middle term is a 1, and so it's a special case only for if the x squared has like something attached to it. So since it's 2 in this case, and the middle term is 1, so 1 is one of the solutions. It would be negative 1 if it was positive, and then you can take the c over a. So, it would be negative 1/2.
Nice. Yeah. So it's effectively the same thing. You're just sort of thinking about things differently. So that's great. Whatever method, if you're more comfortable with another sort of method, this is all very mechanical. There's no math in this method. So by all means, do it your way. And that's you got the right answer. So that's what counts. And Selena has asked, I thought the numbers that added and multiplied had to be the same. So the numbers that added and multiplied. So I'm not sure if you're referring to the way I've shown you or to the way someone else has shown you, because those might be different things. But basically in this method, you want this number times this number when added to this number times this number to give you the middle term. And that's what we got here. Does that make sense, Selena? Yes, okay, great. Okay, so let's just do a few more examples and then I will let you all go and devour the rest of the worksheet. How about this one? This is definitely not a special case because we have this big 35 here. We could use the quadratic formula, but now you can start to see where the quadratic formula becomes very clumsy, right? Because you have that term 4AC, and AC here would be 35 times 12. And so you're doing big multiplication, and then you're taking the square root of big numbers. So you can see where the quadratic formula is inefficient. So can anyone tell me how to factor this?
Using my way, it would be negative 12 over 35, so it would be negative 4/7 as one of the solutions.
Okay, I'm gonna write your solutions, and let's see if we got the same thing.
I'll check the other one.
In the meantime, can someone tell me sort of how to do this using our method? Okay, so Alexis nicely posted in the chat.
3/5.
3/5. Okay. So let's see if we get the same thing. And so Alexis said, and I'll sort of deconstruct your method a little bit. So you said that 7 times 5 gives you 35. And I need to pick, it's kind of tricky because you have to pick numbers that, to where this cross multiplication kind of thing works out. And it turns out that 4 and -3 would give you, sorry, I should be writing x's here because those are the factors. It turns out that, when you do 7x times 3 times -3, that gives you -21x. And when you add that to this times this, which is 20x, you indeed get the middle term, which is -x. So Alexis, you're absolutely right that this is the right factorization. And now I would find the solutions by setting this equal to 0. And we do get the same solutions that Adi said a while ago. So good job to everyone who helped. Okay, any questions about that? So I'm kind of going fast. Does the mechanics of it make sense if this is new to you? Yes, okay, great. Okay, how about this one? I'll probably make this, we'll do 2 more and then I'll let you get to it with the rest of that assignment. So is this any different, first of all? So you see these pies. Does the pie make things harder?
No.
No. So how would I go about this? What are factors? You have to start somewhere. So what are 2 numbers that add up?
Like some solutions.
Or tell me factors that multiply to 50x squared.
So 25 to 510.
Okay, so let's try some of these. I'm going to try this one first. Okay. What about this side? What are 2? There are only 2 numbers that multiply to pi.
Yeah, pi and negative pi.
And because I have this negative sign, one of them is going to have to be negative. So I'm going to let this one be negative. And it turns out, let's see here. Yep, this gives us the right. So 10x times pi is 10x pi. And then when I add that to 5x, that gives me negative 5x pi. And that, lo and behold, gives me the middle term. So this is the correct factorization, right? So we could, like Adi suggested, some other factors, but these factors would not have been. So 25x and 2x does.
Yeah, that wouldn't work.
Mm-hmm. But it's good to, honestly, this is very much trial and error. And we are guessing solutions. We have some constraints, but this is not like a general solution, right? If you want to like get the solution to a quadratic equation the first time, then you're sort of confined to the quadratic formula. But anyway, yes. So your factors would be 10x minus pi times 5x plus pi. And then what would your solutions be? So Adi has said that, let's see, negative pi over 5 and pi over 10. So let's see. This is just algebra, right? Just basic linear algebra kind of things. So these are your two statements when you apply the zero product property. And from here, you would have x is pi over 10. And from here, you would have x is, oops, what is that? People are messaging in the chat. And then the solution to this is negative pi over 5. So yes, so those are the correct solutions. Is this making sense? So don't be afraid by weird.
So those answers are right?
Those are, yeah, you got them right.
Okay.
Mm-hmm. And so someone else asked, so Long, you asked, is there another method if the coefficients are huge numbers? The number of times that you would be able to guess, okay, you sort of, in real life, it's very infrequent to be able to just guess solutions to a quadratic equation, but on the SAT, I think almost every question, I don't think you'll need the quadratic formula much. There might be like a conceptual question about the discriminant or something more conceptual about the quadratic formula, but I don't think you'll actually have to use it and take the square root of some ugly number. But in real life, people generally just plug the stuff into a computer, and if you have a horrible problem. But our goal is to sort of develop intuition. Okay, so let's just do one more, and then I will let you all go. So this is an inequality, right? Because of this. So now we're sort of so we're going to talk a lot more about this tomorrow, sort of putting everything we've learned in the course so far together. So we're going to talk about quadratics and inequalities and absolute values all at the same time. So this is a little teaser for tomorrow. So what are factors that add up or that multiply to pi squared x squared? There are not many options, so it's hard to go wrong. Just shout it out. Pi and x, thank you, yes. So you could have also picked, pi squared, like x squared, you see what I mean? So there are other options, but this is a good choice. How about factors that add up to negative 10? That I keep saying add up, that multiply to negative 10. How about negative 10 and 1? And cross multiplying, right? It's not really cross multiplying, but that's what I sort of call it. You have this times this plus this times this. And that gives you the middle term. And so this is the correct factorization, right? And then we can write the factors pi x minus 10 times pi x plus 1. And y is less than or equal to this entire thing. So now how do I deal with the inequality? We actually did a problem a lot like this when we were talking about inequalities, but I sort of started with this stage. So I can graph this thing, right? So if I set this equal to 0, I would have the x-intercepts 10 over pi and negative 1 over pi. Everyone agree? Okay, and so if I were to graph this, here's 10 over pi, and here's negative 1 over pi, and so the entire thing looks like this, and y has to be less than or equal to this graph. So can someone tell me where to shade my solutions? Do they lie above or below the graph?
Solutions?
Yeah, so this so this is an inequality. We talked about how inequalities are less restrictive than equalities, and generally the solutions to inequalities include whole sets of numbers, not just.
Oh, so if it's less than, it would be below.
It would be below, yes. So someone said above in the chat. Do you understand why it's below? It's because, yeah, just because you have this less than sign. So all of this space is below the graph, and so pick any number, like, I don't know, negative 10, 10, and if you put that in here, you'll get a true statement. So therefore, that point is a solution to this equation. So we're going to talk more about inequalities tomorrow and sort of how they relate to quadratics, and then it gets really interesting when you start putting absolute value bars around quadratics. But at this juncture, I think I will let you continue on that assignment. It's 10:45, so just keep in mind that on this assignment, you're not given equations, you're given expressions, and therefore you're not asked to find solutions to equations, you're just asked to factor. So don't go find, don't go setting things equal to 0. That would be kind of meaningless. And yes, Selena, you're supposed to email it to me, and I will put in my email right here. Okay, so Alexa's finished. So if you finished, you're free to go. Sorry for the weird, for the sounds from my apartment today. I hope that's gone tomorrow. Thanks everyone for bearing with the weird structure of this class. Tomorrow will be really interesting. And as usual, the Thursday class is geared more towards the juniors and seniors. So it should be very helpful for your sort of upper level math. And so people are asking, is there a quiz? There is no, this is sort of the quiz. This is like, and Aruhi, yes, you send the problems to me. And I just put my email in the chat. You might have to scroll a tiny bit. Okay, Isaac, you said today is interesting. I'm glad you think so. Someone is asking, will this be a grade? It will be. It will be a grade. And there might be something special for someone who gets a perfect score. So. Yeah, with that, you're free to go. You're free to stick around. If you have questions, feel free to ask. Thanks again, everyone. Patience today. Not long, a Scooby snack. No, but